In this video, we are going to focus on the chapter of binomial theorem, and the skill that we are focusing on for this video is how do we expand a given binomial, let's say a plus b raised to the power n, whereby the power n is a positive integer. So to start off, we will first look at what is given in the A math formula sheet. We know that in the A math formula sheet, we are given this section over here related to the whole binomial theorem chapter. And in this section here, we need to be able to identify how do we make use of what is given in the formula sheet. So if you look at the formula sheet, right, you can see that I have a plus b raised to the power of n given by this entire expansion over here. And from this expansion, you need to be able to see some very important key terms. For example, all these big long brackets here, n1, n2, they actually read as n choose 1, n choose 2, for example. So what does this n choose 1, n choose 2, or n choose r mean? So actually, they can be represented by this formula here, n factorial over r factorial times n minus r factorial. And you can actually key all these results into your calculator very easily if you know what is the n and r. So n represents the power of that the binomial is raised to. R represents the relative position of the terms. So for example, in this case over here, the first term, this is term 1, term 2, term 3, for example. But the r position starts from 0. So actually over here, first term, my r equals to 0. Second term, r equals to 1. Third term, r is equal to 2. Okay, so once you are able to identify these important things, then we can move on to learning how to apply the binomial theorem when you want to expand different binomials. Okay, so let's look at what we need to know for this skill. Example 1. Expand this binomial raised to the power 5 in ascending powers of x up to the term in x power 3. So what I just need to do is I simply look at the formula here. Okay, first step, when we see this binomial, in order to not make careless mistakes, we should first identify what is my a, what is my b, and what is the n. So from this expansion here, we can see that from here, I know that a is the first term, a is equal to half, b is the second term, and this second term here is negative 2x, not just 2x, but negative 2x, encompassing the sign in front multiplied to the coefficient. This is negative 2x, and the power here, n, is equal to 5. Once I've identified this, then it will be very simple to apply the formula in order to find what is the expansion. So over here, half minus 2x, the whole thing raised to the power 5 is equal to, by the formula here, a power n. So this will be half power 5 plus, the next one is, n choose 1 times a power n minus 1 times b. So n choose 1, it will be 5 choose 1 times a power, now this n minus 1, so 5 minus 1 will become 4. And this b here is negative 2x. Then we follow the same pattern. The next term will be, based on the formula here, n choose 2, a power n minus 2, and b squared. So therefore, this will be 5 choose 2 times half times power 3 times 2x, the whole thing square. Then if you follow the pattern, you'll notice that by this pattern over here, I know that the next term would be simply plus 5 choose 3 times half, the whole thing square, times negative 2x, the whole thing power 3. Okay, and over here, the question says only up to the term in x cubed. So therefore, I notice that from here, I will already get the term in x cubed. If I continue further, I will get terms with x power 4, x power 5, etc. So you can stop here, and I represent this by a plus dot dot dot. This is important because you are telling the marker that you know that there are still more terms over here, but because the question only wants us to find up to the term in x cubed, I can stop here and replace the back part with a plus dot dot dot. Okay, then my next step is to simply calculate all these values. You can use your calculator to simply simplify everything over here. So the first one, half power 5, I know that this is 1 over 32. Next one, 5 choose 1, you can key this in your calculator. 5 choose 1 is simply 5 times half the whole thing power 4, which will give us 1 over 16 times negative 2x plus 5 choose 2. 5 choose 2, if you keep this in the calculator, it will be 10 times 1 over 8. And this thing here, remember this is negative 2x power raised to the power 2. So this, the negative will become positive. So this will become 4x squared plus the last one, 5 choose 3. You'll notice that 5 choose 3 is also 10 times half square, which is 1 over 4. Then this is negative 2 power 3. Okay, negative 2x power 3. Any negative number raised to an odd power will still produce a negative term. So this will be negative 8x cubed plus dot dot dot. Okay, then from here simply we just need to combine all the remaining terms over here. So therefore this will be simply 1 over 32. Then over here the next one is 5 times 1 over 16 times negative 2. This will become minus 5 over 8x. Okay, then plus, next one is 10 over 8 times 4, which will become 5x squared. Then the last one is, I know that this is a minus sign, so this will become a minus sign here. This will be 10 over 4 times 8. And I'll get minus 20x cubed plus dot dot dot. So with that, by simply being able to identify which is your a, b, and n, and then applying into your formula directly, you can easily expand binomials raised to a certain power here, as what we have gone through in this video. So that is the end of the applying this skill in using binomial theorem to expand given binomials.